We're continuing our discussion of the graphs of the trigonometric functions, and in this video we're going to take a look at the graph of the secant function. Okay, so again, I've provided you with the unit circle, and if you'll recall, with the secant, it is the reciprocal of the cosine, which means you're going to have 1 over the cosine of x, or remember that the cosine corresponds to the x coordinate of the ordered pair. And so in the table here at the bottom, again, I've referenced the cosine so that it makes it a little bit easier as we think about the values for the secant. So if we start out with the secant of 0, we would have the reciprocal of 1, which would be 1 over 1, which has a value of 1. With the secant of pi sixths, it would be the reciprocal of the square root of 3 over 2, which becomes 2 over the square root of 3. But we know we can't leave that radical in the denominator, so we have to rationalize the denominator by multiplying by the square root of 3 over the square root of 3, which ultimately gives us 2 on the square root of 3, all divided by 3. And in a decimal, if you converted that to a decimal, that's going to be approximately 1.15. Okay, then let's look at the secant of pi fourths. Okay, so the secant of pi fourths is going to be the reciprocal of the square root of 2 over 2, which is 2 over square root of 2. Again, I realize I have a radical in the denominator, so I'm going to rationalize, multiplying by the square root of 2 over 2, which gives me 2 on the square root of 2, all divided by 2. And then since I have a 2 in the numerator and a 2 in the denominator, they divide out, and I'm left with the square root of 2. The square root of 2 is approximately 1.4. Now we're up to the secant of pi thirds. The secant of pi thirds would be the reciprocal of 1/2, which becomes 2 over 1, or 2. And then we have the secant of pi halves, which the cosine of pi halves is 0, so we're going to end up with 1 over 0, and we've talked about that several times already, that presents us with a problem because our function becomes undefined at that value, because you cannot have 0 in the denominator of the function. And so then once we get that first quadrant, we can kind of use that, because we know that every sixth is going to be 2 square root 3 over 3. Every fourth is going to be square root 2, and every third is going to be 2. We just alter the signs, S-I-G-N-S, based on the quadrant we're in. In quadrant 2, the cosine is negative, and therefore the secant would also be negative. So at 2 pi thirds, I'm going to have negative 2. At 3 pi fourths, I'm going to have negative square root 2. At 5 pi sixths, I'm going to have negative 2 square root 3 over 3. Then when I get to pi, I have the secant of pi. Pi has, I lost a negative sign there. Okay, the cosine at pi is negative 1. So we would have 1 over negative 1, which simplifies to -1. Continuing into the third quadrant. In the third quadrant, our cosine is also negative, which means the secant will be negative in the third quadrant. So at 7 pi 6, I have -2 square root 3 over 3. At 5 pi 4ths, I have negative square root 2. At 4 pi thirds, I have -2. Then I have the secant of 3 pi halves. The cosine at 3 pi halves is 0. So again, I run into my problem because I have 0 in the denominator. So at 3 pi halves, again, my function is undefined. Finally, in the fourth quadrant, my cosine is positive, so the secant would be positive in quadrant 4. At 5 pi thirds, we would have +2 is the secant of 5 pi thirds. The secant of 7 pi fourths would be positive square root 2. Secant of 11 pi 6 would be 2 square root 3 over 3. And then I'm back around to 2 pi or 0, where we already know that the secant is 1. Okay, so then we want to look at how to graph those. And again, I want to connect the graph of the secant to the graph of the cosine. So again, I begin by drawing my axes. Okay, so we have our vertical axis, which is y. We have our horizontal axis, and we typically use our quadrantial angles. So we have 0, pi halves, pi, 3 pi halves, and 2 pi. We could also rotate negatively, so we would have negative pi halves, negative pi, negative 3 pi halves, and negative 2 pi. And on the y-axis, we generally mark our 1 and our -1 from the unit circle. So again, I want to start out by graphing the cosine, so again that you can get a sense of what this thing looks like. Remember, cosine begins and ends at 1, it mids at -1, and is at 0 in between, so that you get this curve here. If I go backwards, again, it begins at 1, ends at 1, mids at -1, and is at 0 in between. Okay, so again, in blue here, I've graphed the cosine function. So let's think about what the secant would look like. Okay, to graph the secant, again, wherever the cosine is 0, your secant is going to be undefined. So that's going to be at pi halves, and we would have a vertical asymptote there. It's going to be at 3 pi halves. So we have odd multiples of pi halves. At negative pi halves and at -3 pi halves, you have those vertical asymptotes because the function is undefined. The secant is undefined at those points. And then again, if we think about and use the idea of the reciprocal, the secant at 0 was 1. At pi 6, it was, let's see, what was it? I can't, pi 6, back up for a second. At pi 6, we had 2 square root 3 over 3, which is roughly 1.1. So you're going to have this little curve going up. pi fourths, we were at square root 2. At pi thirds, we were at 2. So you get this arced curve. Again, think about flipping that curve. If you go to between the asymptotes and you have -1, again, think about that curve flipping over, okay, as the reciprocal, and then you have kind of this other half of the curve. If I go the other way, again, if I flip this up, and then I would flip this one down, again, you have to stay between the asymptotes. And so here's the curve. Basically, your secant in red, you start at 1, you end at 1, you mid at -1, and you have asymptotes in between, if you want to think about it that way. And again, you kind of have those U-shapes. Sometimes we'll actually back up and start it here at -pi halves so that you can get the entire upper curve in your picture when you start. But again, to get the upper half, the right half of the upper curve, the left half of the upper curve, so the right half, the left half, and the lower curve, you do have to go a full revolution around the unit circle. So your period is 2 pi, and then it starts repeating itself. So let's take a look at the characteristics of the secant. It is a function. It does pass the vertical line test. You can use any number for the domain except the odd multiples of pi halves. So pi halves, 3 pi halves, 5 pi halves, 7 pi halves. Again, with the range, if you'll notice, there's no values between -1 and +1. It would kind of be just empty there. So we don't have any value in the range. So the range goes from -infinity to -1. Then it jumps to +1 to +infinity. It is periodic. Your pattern repeats. And the period is 2 pi. It is even. It's symmetric to the y-axis. There are no zeros. It does not cross the x-axis at all. The y-intercept is 0, 1. And again, your vertical asymptotes occur at the odd multiples of pi halves. Now here again, there are not a lot of, you don't see secant used a lot because it is the reciprocal of the cosine. So in most cases, we would use cosine. It just makes the problem a little bit simpler rather than using secant. But basically, anywhere you can apply cosine, you could feasibly also apply secant. But again, the primary thing to remember is that basically you start at 1, you end at 1, mid at -1, and you have asymptotes at pi halves and 3 pi halves or in between.